Okay, this is the second video in 6-7. Let's look on, name that graph. Let's look at number 3 together here. Again, we're trying to find a sine and a cosine equation that accurately represent this graph. So looking at the amplitude, we've got 1 minus -3 over 2, or 2. So if the amplitude is 2, that means, let's just make this a little bigger. That means that the midline here will be at -1, which happens to be a point that we have goes through there. Okay, so the vertical shift then is down 1. Okay, I think it might be easier to start by finding a cosine graph here, because if I look closest to the y-axis, cosine starts at its highest point and goes down. So it looks like finding a cosine graph that shifted to the right a little bit may be the way to go. So let's do that. So y equals 2 cosine bx minus c, and then shifted down run. Okay, so let's unfortunately I don't have a high point and a low point, and I don't have the points to kind of give me a good sense of what my period is, hence what my b value is. And I can't from my points tell the shift for cosine. I actually could for sine, but let's do cosine first, and then I'll talk about how if I started with sine, I actually could do the horizontal shift. But but I'm getting ahead of myself. So, all right, so let's plug in points here. So I know this 7 pi over 4, comma 0. So let's plug in for x and y. 0 equals 2 cosine 7 pi over 4b minus c minus 1. So isolating the cosine, I get 1/2 equals cosine of 7 pi over 4b minus c. Okay, so what's important here is I want to find out what angle specifically when I take the cosine I get 1/2. Well, if I'm saying that my cosine graph normally would start here, then this point here is corresponding to an angle in quadrant 1 when I'm going from my highest on my way to the midline. So the quadrant 1 angle, when I take the cosine that gives me 1/2, is pi over 3. So that means I need 7 pi over 4b minus c to be equal to pi over 3. Okay, that's one equation. Now let's get another equation. And so then I'm going to end up with 2 equations and 2 unknowns. All right, so using my other point, I've got -1 equals 2 cosine 9 pi over 4b minus c minus 1. And we end up, when I isolate cosine, I end up with it equaling 0, which makes sense because this point is on the midline, and which for cosine means equaling. So where does cosine equal 0? Well, cosine equals 0 at pi over 2. So it goes down to my midline at pi over 2 from its highest point. So I'm going to set 9 pi over 4b minus c equal to pi over 2. Okay, so now I've got here I have my 2 equations and 2 unknowns. So let's just solve this system. I'm going to subtract this equation here from the 1 equal to pi over 2. So I'm going to multiply this equation here by -1. So I'm going to get -7 pi over 4b plus c equals -pi over 3. And that will give me pi over 2b equals pi over 6. And solving for b, I get 1/3. All right, so let's plug back into one of these equations to get what c is. Maybe I'll do the top one. 9 pi over 4 times 1/3 minus c equals pi over 2. And let me just bring this up a little bit. Okay, so we've got 3 pi over 4. I'm going to bring over the pi over 2 equals c. So in this case, c is equal to pi over 4. All right, so I have my pieces for my cosine equation. Y equals 2 cosine. My b value is a third x. C is pi over 4 minus 1. Okay, perfect. That's for my cosine. And then for my sine, remember, if we have one, we can just do pi over 2 minus to get the other. So I'm going to say y equals 2 sine 90, or pi over 2, minus my angle, which was inside the cosine. And so let's keep moving this up here. Whoops. So I've got y equals 2 sine, it's going to be negative 1/3 x plus 3 pi over 4. But remember, we don't want a negative coefficient of x, so y equals 2 sine. If I take out the negative, I get 1/3 x minus 3 pi over 4, and sine of negative an angle is negative sine the angle, so y equals negative 2 sine 1/3 x minus 3 pi over 4 minus 1. So those are your two equations, but I want to go back and show you how I could have started with sine here. Because notice I did have this midline point, and I know that sine starts on the midline and normally goes up. So if it's starting on the midline and going down, then I'm going to write this in red. Then I could say this. That means a negative in front of the amplitude, because it would have been flipped. Instead of going from the midline up, it's going the midline down. So I would have said negative 2 sine. And I don't know my b value yet if I were starting from scratch. But if I'm saying that my graph has been shifted over 9 pi over 4, I could say x minus 9 pi over 4. And then I still have that vertical shift of down 1. And then really I just need to plug in this here point to find my b value. And so then I just end up with one unknown. And notice when you should get, if you've done it properly, you will get the b value being 1/3. And let's see what happens with this equation. We should get exactly what we got before. So if I plug in 1/3, then y equals negative 2 sine. This will be 1/3 x minus 3 pi over 4. And then, of course, we still have the minus 1. So notice that's exactly what we got before. So you could have started with a sine with a negative in front of the amplitude, but you have to recognize that. And just remember this form. If we're putting in what the vertical shift is, it has to be with that b factored out. Because the vertical shift is happening after the period's been changed. Okay, so that's video 2. There's something else I'm going to explain. It gets a little bit more complicated, or different, I should say, in another video. So I'll go over number 6 in video 3.